Well, first up, I'm very happy to have Samuel here from Bluesky. He's going to talk about videos, how they build videos on Bluesky essentially. And so, a round of applause for Samuel.
Thank you. Yeah. Should I wait for the thing to appear? But yeah, I'm Samuel. I work for Bluesky, and I have done for about a year now, just over. And I wanted to cover in this talk just how videos work on Bluesky, because it's a little bit complex and convoluted, but yeah. Is the screen working yet? Uh-oh. Uh-oh.
Well, this is the point.
Oh, okay. Keyboard setup assistant. What?
We can take that away.
Quit. Okay. Let me try screen sharing again.
You need to now do, I guess, this. Mirror extend display.
Okay, yeah. So choose
Sorry, I thought that was already done.
entire screen.
This one, yeah.
Okay. Maybe.
Perfect.
Yeah, how we added videos to Bluesky. This is not a video, this is a presentation. It's different. Not my specialty. Yeah, as I was saying, I'm Samuel. I work at Bluesky. And so when I joined a year ago, we'd launched, we'd had a bit of influx of users, but it wasn't feeling feature complete yet, and we were at a bit of a fork in the road. We don't have capacity to do videos and DMs at the same time. We've got to pick one, and we picked DMs. But then we built video, and yeah, I wanted to first kind of cover our process on like how we build features at Bluesky, because we're a pretty tiny team. I think at the time it was under 15 people. Now we're just over 20, but that's building an app at this scale is like, it's difficult. So our process is this. Each project has a DRI, a directly responsible individual, and they own the feature, and they are responsible for like shepherding it through. So keeping the project tracker up to date, like syncing with leadership so they know what's going on, running the meetings, that kind of thing. In video's case, it was a big project, and like the back end and the front end, like so on the front end, it was Haley and I adding like a video player to the app. That's quite complicated. So that was kind of its own sub-project. So I DRI'd that, and Devin was in charge of the back end, which is mainly what I'll be talking about today. So first, what we do, we plan thoroughly. We write a doc, and we figure out like both what do we want the feature to be, but also what can we do. Like we have a lot of limitations. Like building decentralized systems is quite difficult, and we have different constraints to like normal applications, you know. So there was a lot of fact-finding, just like figuring out how much can we shunt onto the client. It turns out web browsers are not very good at video processing yet, so it ended up being a lot of processing on the server. But we needed to find that stuff out. So we wrote a bunch of docs before we started, before we hit the keyboard and started typing. And then we built it. So small teams. I think on this one, 4 to 5 people working on this out of like a total of 12. And then we launch it, and then repeat endlessly until we've built an entire social media app. So what's the plan? So I need to give a bit of a background on how blobs work on App Protocol. So we've got the 3 major parts that kind of work together, right? There's the PDS, which is where your data lives, the app view, which collates everyone's PDS data and turns it into a social media app, and then the client, which is an app that you look at. So say I want to post a selfie. So first, I upload selfie.jpg to my PDS, and then I write a record that references this selfie. You might, so in this case, in my kind of pseudocode, I'm just like selfie.jpg. The problem is, like, what if we upload 2 selfies and they're both called selfie.jpg? How does it know which one is which? Which one is the real one? what we can do is we can use a hash function to hash the image. And so a hash function, if you don't know, it finds it deterministically will take, usually like a string traditionally, but you can also do it to images. You can deterministically get a hash of the image. And so if you run the same image through a hash function again, you'll get the same output, but you put a different image in, you'll get a different unique thing. And what we can do is we can use it as its name. And in a sense, it's almost like its true name, right? It's the name of itself. It's not just what you've called it, it's what it actually is. So yeah, we pass our selfie in and we get its actual name. And it's a long string, so I couldn't fit it on the slide, but like that is the actual hash of this, start of the hash of this image. So this is content addressed. So if you work with app protocol, you might see a lot of SIDs. That's what it is. It's the content ID. And how that's found is you hash what the content is. So yeah, if we now name the file that, there's no, like, it's absolutely going to be that image. And this comes with some interesting properties. So first of all, like, we know, a file only has one name. It's pretty clear what that name should be. You don't need to worry about, selfie brackets 1, selfie brackets 2, like you do on your files, like you do in your, on your computer. You can also verify that that image actually is that. So say you ask someone for so-and-so SID, and they give you the blob back. You can run it through the hash function yourself and confirm that they've actually given you the right one. So this is very important in like a kind of trustless network. You don't actually need to trust that the CDN, that if you're trying to get a blob off someone else's PDS, you don't have to take their word for it that it's actually the right image. You can verify yourself. You can also find any blob on the entire AppRoto network from just a DID and a SID. What the DID does, a DID is a pointer to a PDS, pretty much, and a SID is a pointer to an image, and the images live on the PDS. So if you have a DID and a SID, you go to the PDS, you ask the PDS for the blob, and the PDS gives you it. And that way you can find it. You can find any image super easily. And in fact, I wrote a CDN in just 74 lines of code. I think I have it. I can't switch. Okay, never mind. But yeah, it's on GitHub. It doesn't do the validation step, which is quite important. I'd recommend an actual production CDN to do the validation step, but it's super simple. It actually shocked me how simple it is to actually write an image CDN. Very easy peasy. So with that in mind, we changed this like selfie.jpg reference to a blob ref. Pseudocode, you can see in the corner what it actually looks like. But this way, it's like a strong link to the actual blob itself. So if you know how AppRoto works, you'll know it goes through the fire hose over to the app view. The app view sees this post for the first time and says, oh, I don't have that blob yet. Please, can I have this blob? And the PDS gives the blob. What the app view now does is it has a image CDN, and it can just put that blob in the CDN. And so that makes it very cheap to serve, and it compresses it to like a standard JPEG or whatever. So if you upload like iPhone photography, it's not going to like completely take 10 minutes to load your feed. It's going to be actually pretty snappy. So once it's in the CDN, we can replace the ref with the CDN URL, and that is what the app view then gives to the client, right? It's a cache, and it doesn't serve the raw content from the PDS. It serves a nice view that a client can actually consume and display to the user. And pause for a little bit of drink. Videos. So why can't we just do that for videos? The problem is you may have noticed that videos consist of a lot of images. So they're very big. They're also a lot harder to process. Processing, like in the system I showed before, like you can do that live, right? An image takes next to no time to process. So whenever an app view sees a blob for the first time, it can stick it in the CDN, and it just works pretty much. Works live. With videos, the processing time scales with the video length. So a 60-second video, like, it depends on how much you're trying to compress it and a bunch of other variables, how fast your computer is, but it scales with the video length effectively. So if you have longer and longer videos, it's increasingly not viable to do it live. There's also a lot more that can go wrong. Like, it's just finicky, difficult. Sometimes it just errors for strange reasons. And so if we just send the video out there with the post, like, what if it fails? Like, would there be no like feedback mechanism? So So with just-in-time being too slow, like, the nature of microblogging is if you're refreshing your following feed, you're always seeing 0-second-old posts. And so if someone's posting a video and you're looking at your following feed, it's not going to be ready yet. It's going to just 404. So what we decided to do was a slightly more different architecture. In this case, the client has a video that we want to post. So rather than just sticking it straight on the PDS, what we do is we take this video and we first send it to the video service, which is video.bsky.app. What the video service does, it has multiple jobs. So first of all, it has to moderate the image. Moderate the video. I will get image and video mixed up a lot. I always do. So first of all, it has to do moderation. Like, we don't want nasty stuff in there. It's got two primary jobs. One is to generate the source file, and the other is to act as the CDN. So, what we want, reset. So the client sends the video to the video service, and the video service, the first step it does is it generates like a standardized, normalized file and puts it on the PDS. So this is like the new like source of truth for the video. So it takes whatever crazy format that the client has and it turns it into an MP4 at a reasonable bit rate. This ensures that it like stays within the limits of the like the PDS's upload limits, and just make sure that just like most videos out there on the network are not going to be crazy formats and uncompressed and stuff. Like it will just be it's a standard format and just is a reasonable size. And so this is now like the real video, and this then gets a content ID. At the same time, it's also doing a different set of processing steps, and it's turning it into a HLS stream. So that's a format where the video is split up into like chunks of about 5 seconds, I think. And then these chunks are in multiple different sets of quality. So then the client can like dynamically switch qualities and stuff. That's how proper video players work. So it's chunking and splitting it up and doing all sorts of magic to turn it into a HLS stream. And that's in a playlist file in the CDN. And then it shunts all those chunks to the CDN. When the video service is done, it returns this blob ref to the client. And then what the client can do is it can now make the post, but it can do so with the confidence that the video already exists and it's already processed. So when it goes through to the app view, like the app view can just turn it into the CDN URL, and it's ready to send to the client straight away. There's no lag in the processing. So this comes with a lot of benefits. So like videos will be available instantly, and they can be certain that they will work. Like a video that has been processed will work. Fingers crossed. I mean, we had to iron out some kinks initially, but yeah, we're pretty sure it's going to work. It's in the CDN. But if it doesn't work, the processing error can be given to the client while they're still in the composer. We don't need to send them a processing error like after they've sent it, 'cause that's super awkward. Like, what do you have to do? Like, open the composer again? Like, the post already exists. So errors are a lot easier to handle, and it also means that like the videos out there on the PDS are like pretty reasonable. So your PDS isn't full of enormous iPhone videos that are ridiculously huge. But this isn't actually the only path. So the thing about our protocol is that we might not be the only app view out there, and we might not be, and other clients might be using a different video service. Like we see this quite a lot. And so what we have is this quote unquote fallback path that acts pretty much exactly the same as the image flow, as I was talking about earlier. The video service watches the fire hose, and if it sees a video blob that it hasn't actually seen before, it will then kick off that processing job as if it was just like with the image flow. This is a lot of this has downsides, so errors are just get swallowed and it's just 404s forever. And they're gonna 404 until it's finished processing, just by its nature. And of course, the source video on the PDS, it's probably, who knows what it looks like, it's probably huge. But it ensures that other participants in the network, everyone, the source of truth remains on the PDS. And so that's how we operate in a multi-participant world, right? We listen to the fire hose. This happy path is an optimization step for making apps that kind of meet user expectations, but the fallback path is ensures that we're behaving responsibly on the protocol. So yeah, some weeks later we have video. Come talk to me separately about the challenges with making the video player, because that was not easy. But this is more of a protocol talk. I asked Jazz for the latest stats, and apparently we have served 5,000 years of video to date. That's 69 human lifespans, apparently. What was happening 5,000 years ago? The first dynasty of Egypt. We hadn't added the rocks to Stonehenge yet. It was still a ditch. They were inventing written language, and the world all this dam was being built. So yeah, that's a long time, and we have some frankly depressing graphs of how many lifespans we're serving. Jazz is awesome, by the way. They did a tremendous job building this insane processing architecture that's able to handle the enormous load of the network. So yeah, shout out to Jazz and Devin and everyone else on the team, of course. Yeah, that's all. Protocol Pals part of Starter Pack. I'm sure you're already following all, but no harm in doing it again in case I've changed it. Cool. Thank you very much.